Crystallization video part 1. We will learn about crystallization through an easy science experiment. So here is the sign for crystallization. Background on crystals and their importance in everyday life. Let us first understand what a crystal is. When we say crystals, one may think of diamonds or quartz. But do we have crystals in our day-to-day life? Yes, there are plenty of examples that most of us see and use daily. Crystals are all around us in everyday life. They range from common and inexpensive items such as salt and sugar to much more expensive and rare items such as diamonds and other precious stones and minerals. It is worth noting that a crystal is a state of existence for a substance, and anything can be a crystal in specific situations. Crystals are present there in these items. The process through which a substance is made into a crystal is called crystallization. Crystals are solid in nature. Most commonly, crystallization is the natural or artificial process for the formation of solid crystals from a solution using different kinds of processes and techniques, which are different on the basis of the substance being used. It is possible to grow crystals in other ways too. There are more complicated and artificial crystals which are used in scientific processes. For example, crystallization is based on the principles of solubility. Compounds, called solutes, tend to be more soluble in hot liquids, solvents, than they are in cold liquids. If a saturated hot solution is allowed to cool, the portion of the solute that is no longer soluble in the solvent tends to be released from the solution and forms crystals of the pure compound. For example, we can get crystal form of salt through crystallization process from the seawater. Additionally, allowing metals to solidify from their melted states. The electronics industry relies on growing single crystals of silicon in this way. We have two major questions, like what is the meaning of solution? Is the mixture of solvent and solute called a solution? Here is the answer of the two questions. For example, if we consider lemons as the disappointments and challenges which we may face in our day-to-day lives, a good way of managing such situations is to simply add some sugar and some water and prepare lemonade. The sugar and water here may represent a different point of view and our efforts and hard work, and in the end we get our lemonade in the form of success. In this example, the lemon and sugar can be called the solute and the water can be called the solvent. The combination of the two forms a solution. However, there is a limit to how much sugar can be mixed into a glass of water. When we mix the sugar, where does it go? And the same goes for tea or coffee. Sometimes, even if we mix the sugar well, we might find some left over at the bottom of the glass. Is that the leftover sugar that cannot be dissolved now? The liquid substance, water or any other, is in our solvent, and the solid crystals which we mix into the solution. For example, sugar or salt are solutes. When these solutes and solvent mix together, then the end result will be called a solution. In a solution, a characteristic property is the inability to identify which part is the solute and which part is the solvent. In life, most of such examples can be seen in aqueous solutions. or solutions with water as the solvent. Crystallization is also a useful chemical technique to separate or purify a solid in its pure form from a solution. This is done by dissolving the sample in a hot liquid, making a saturated solution. Anything that does not dissolve in the hot liquid can be removed by filtration. And what part of the solution remains can then be used to grow pure crystals which can be collected and dried. What is crystalline? Or what is a crystalline solid? A crystalline solid is made up of atoms or molecules which are arranged in a repeating pattern and stacked over and over again, very much like a three-dimensional brick wall or several layers of stacked blocks on top of one another. The way we make a building by placing one brick over the other to strengthen the whole building, the same way the atoms can also connect over and over again, forming a strong structure in crystals. In many ways, looking at a crystal is the one way that human eye will ever get to observe the hypothetical order of atoms and molecules. We can see the structure of atoms in solutes dissolved in water and atoms present in the crystal on the screen. We are all now thinking about the history of crystallization. Just over 100 years ago, a team of father and son, William Henry and William Lawrence Bragg. We can see their images here. They first showed that X-rays can be used to map the positions of atoms within a crystalline solid and determine its three-dimensional structure. This process was called crystallography. And to help celebrate their victory, 2014 is the International Year of Crystallography. The two Braggs were awarded the Nobel Prize for this discovery in 1915. And at the age of 25, Lawrence Bragg is still the youngest ever winner of the Nobel Prize in the sciences. Since this discovery, nearly 30 Nobel Prizes have been awarded which have used crystallography.